I'm Erik.
Hi, Erik.
How's everybody doing today? You guys having fun? See some good talks? Cool. My name is Erik Taubeneck. This is all my relevant info if you want to follow me or check out my code or anything like that. I will eventually put these slides up on GitHub now that they are finalized. So today I'm going to be talking about SQLAlchemy and race conditions, and specifically about creating a get one or create function implementation. So just a real quick before we get started, I'm currently consulting for a company called AlphaWorks. It's just a crowdfunding for equity site, pretty new. They were kind enough to listen to this talk for me and give me some suggestions, so hopefully they made it slightly better for you guys. And also, shout out to Hacker School. I am a Never graduate. If you guys don't know about Hacker School, it's an awesome place to go and spend 12 weeks becoming a better programmer. If you'd like to talk about it more, I'd be happy to talk your ears off about it. So let's jump right in. So here's just a little quick outline for what I'll go over in the talk. So we'll just start with a real simple application to sort of motivate the idea. We'll take a first stab at get one or create. We'll talk about the class method decorator and work that into our function. We'll stumble upon an unexpected exception. In that, we'll discover a race condition, and then we'll solve it and get to our final function. So here's just a real simple application to sort of motivate the idea. We have an example app. It's just like a site that tracks our users' activity on various gaming sites. So they, auth with an external site like gaming.com. I just made these up. And if you beat a game, we store that, and maybe we use that to recommend, or I don't know. We're just storing the information. We're not really worried about why we need it right at this point. Quick disclaimer, I was using a Flask app, SQLAlchemy with Postgres. Some details may be slightly different depending upon what database you're using on the back end. So I would test these things out before you just take the solution that I come up with and paste it into your code base. But the idea here is less about the actual function and more about the process that is gone through to write that function. So there's some APIs. We have this gaming.com, and they have a couple relevant routes to our application on their API. One gives us the IDs of the games that a user has beaten, and the other one just gives us relevant data about a game that maybe someone has beaten or not, but we can just ping it and get the name, the category, stuff like that. So given that API, we create a few classes. Here we have a game class, a game beat class that just sort of relates a user to a game, and then also just a user class. Notice how the API access is just wrapped into that user class. That makes it nice and easy. We'll use that later on. So here's sort of a first stab at loading this data into our database. It's quite messy. There's a bunch of repeated logic. We're making extra queries that we may not want to be making. We're doing a count just to see if the thing exists or not. This code is begging to be refactored and bundled up and made to look nicer. So we're gonna write a function, get one or create, and so it's just going to take our session because that's needed to deal with the database, and then the model that we want to either get one or create, and then some keyword args that specify how we're going to identify that instance of our model. And so we're going to try to get it, and if we can't get it, it's not there, we'll get this no results found, and so we'll just create it, and we'll return that thing. So that's pretty cool. And this allows us to clean up that little script for loading this data. I mean, this is already way more awesome. So cool. Let's keep going. So the next thing we may want to do is using the class method decorator. If you haven't seen this before, it's a pretty cool little function of Python. Basically, by adding the class method decorator, it just makes that method available on the class object. And what gets passed in, where it's usually self, is the class that's being passed in. And so right here, we're using it to create an instance of the object, because for us, all that really concerns us with this object is the provider game ID. And then what we can do is make this API request to get the rest of the data, pull that out, and then return this now it's instantiated object of that class. So this is pretty cool. However, it's pretty obvious that this isn't going to work with our get oneorcreate function. So let's make it work. All right. So we'll just update our function. So now we'll take a create method and a create method keyword args, additional keyword args to get oneorcreate. And so now if we end up creating the object, we will try to get that create method off the model. If that doesn't exist, then we'll just create the model directly from the model. There is one small little caveat here. If you have created a class and decided to attach on a method using setAttr and using the empty string as the name of that method, which is, I found out, legal Python, this will break. But you shouldn't do that. There's probably a better way to refactor this, but we're just going to accept that as a caveat for this right now. So now we've refactored our data loading script again, and it's even gotten a little cleaner. Notice how like our requests import has completely moved out of the script and is completely on the model. So all the data fetching that we want from the API is actually attached to the models that are using that data. So that's great separation of concerns. All right, cool. So this is looking really good. Oh no, that was unexpected. Okay. Well, there's a few things wrong with this, right? First of all, like why multiple results found like that? This whole idea is we were trying to find either we expect one thing to be there or none. So this is sort of useful in the fact that like, oh, we forgot this unique equal true on the third line here. Our provider game ID, we expect a unique, and we can put that constraint on the database. And at least, with adding that, now we get a little bit more expected exception. So now we're getting, an integrity error. And so that's, it's better. And because the way we named our function, the objective of this function is to either get one thing or create it. And so that means that there should really only be no instances of that object or one instance of that object. So this exception is pretty meaningful. It probably means that we're querying by something that's not a unique field, and we should change that. Or like I did, we forgot to put the unique equals true constraint on, and so when we add that, now we'll get the right exception. But still, this is a problem. We need to figure out why this is happening. How is this getting in there? How could two things be inserted in using this method? So let's take a look back at the script that we're using for loading stuff in. So everything seems to be good except, oh, look, where we commit things is at the very end. So this should be fine if we're running it, in one process, one thread, whatnot. But I had this mapped out to like 8 Heroku dynos, like trying to speed it up, like, oh, let's just let everybody churn at it. And what happens is this loop can take a while. And so, one game ID might come up and that ID is not in the database, and it's cool, it creates it and it adds it to the session, and then some other process. So here I actually have an example. So let's say Dyno3 gets this game ID, it looks for it, doesn't find it, creates it. So then number 3 moves on to the next game ID, it hasn't commit yet. So number 7 gets that same ID. It looks for it, still doesn't find it, so it creates it because dyno 3 hadn't committed yet. Dyno 7 then moves on to the next game ID. Number 3 finishes the loop and commits. Eventually, number 7 finishes and commits loop, and the integrity error occurs. So here's the race condition. And one thing that we might want to do is move those commits right after we add things, so we commit more often. However, remember that when we're doing that, like create from provider ID, we're making an API call. I mean, that could take a few seconds. This isn't going to be good enough. This significantly reduces the chance of a race condition happening, but it's not 0, and we really want 0. Just to demonstrate like how this could happen, number 3 gets this game ID. It looks for it, doesn't find it, so it starts to create it. While it's creating it, 7 gets that same game ID. It looks for it, doesn't finish it, doesn't find it, starts to create it as well. Dyno 3 finally creates it and then commits. Dyno 7 is done creating it as well, and it commits, and now the integrity error occurs. So still possibly going to be a problem, particularly maybe the way that we get the data from the API is sorted by popularity. So like every person that we look at, there's a high chance the same game is going to be right at the top. So this is still a problem. So we need to fix it. So now we basically have to wrap our commits in this try and accept, and if there's an integrity error, then we know that the object exists and it was put in by some other process, and so we can go and grab that. But this is starting to look like that original code that we had written, and that wasn't very good. So there's probably a way that we can do this. This is just gross. So we can put it in our function. So here we just do the try and accept like normal with the no results found, but then we're going to add the thing to the session and commit it, and if that goes cool, we'll return that created object. If we get the integrity error, we'll roll back the session, and then we'll query for it. So this is pretty good. There's one problem, and that session.commit really shouldn't happen in this function. This has to do with sort of architectural design decisions and whatnot. This isn't a technical problem and more of a design decision. However, the SQLAlchemy author strongly discourages doing things like this. So when I first worked this out, this is how I had it, and this is how I had published it on my blog, but I got the suggestion like, hey, what if we use session.flush? And so session.flush essentially will flush your session against the database, make sure it won't cause any conflicts, but doesn't actually commit to the database. So the data doesn't actually get put into the database. So I was like, yeah, maybe that'll work. So I spun up 2 dynos and tested this out. So on the left here, I've created, on left and right, I've created a game with the same game ID, added it to the session, flushed on the left. Then on the right, same thing, added to the session, I flush, and watch, number right hangs. It's hanging, it's hanging. All right, it's hanging, it's hanging. All right, we commit on the left, and bam, integrity error on the right. So this is pretty cool, right? This means that if we do a flush and we haven't committed, then everywhere else, if we try and flush, it's going to hold off and wait until the last flush has cleared out. These are entirely different processes on Heroku dynos. I mean, they could be operating in different data warehouses or whatever. These are completely separate concerns, yet the database is maintaining this sort of ability for the flush to occur. Let me reiterate that this is with Postgres and SQLAlchemy, and with a different backend, it could act a little differently. And I'll just reiterate that this is the author of SQLAlchemy. He was kind enough to show up onto my blog and leave this little comment that it depends on the database and how the transaction isolation is set up. So doing a flush versus a commit isn't a simple answer. I'll take questions. I'm almost done. We're almost done. This is our final version of the function, and all that's changed here is that that line that was a commit has changed to a flush. And so this, if we take a look at the way we were loading in our data, that ugly big script that we had is now pretty clean, pretty easy to read as far as I'm concerned, and looks pretty nice. Yeah, thanks for your time, and I'd be happy to take any questions. That's a good question. Yeah, I believe so. Yeah, as soon as this one is rolled back, it frees up the database, and the other one should commit just fine. I should test that out and post another GIF to my blog. Yeah. 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 So the thing is, if you're using this, you still want to commit often. This will hang the database, but there isn't really any other way to go about this, and you need the process to hang in order to maintain this type of concurrent behavior with a single data source. So yeah. Right. Yeah. Unless, well, yeah, if it was the first one to call flush, then it wouldn't have any issues later, unless you could have probably inserted something into the SQLAlchemy cache that could cause an issue. You could do some invalid stuff or something like that, right? And the flush would fail for those reasons. But assuming that everything's valid, there shouldn't be any sort of race conditions that would cause that first one that called flush to fail. Yeah. Yeah, so actually, probably on this final slide, that db.session.commit should be for over. Yeah, it's a trade-off, right? So the commit is essentially I/O between the process and the database, and so on something like Heroku, that's happening over, HTTP or whatever it is. So it's not even necessarily on the same box. So that commit could take a little while for it to happen. The flush is going to take time as well. I'm not sure if the flush is faster. So that's a really good question. I should look into that. So I think you're already taking a performance hit by doing the flush anyways. So doing the commit shouldn't add a ton to it. It also depends, if you're planning on mapping this out horizontally, committing often is going to be highly beneficial because you're going to minimize the amount of time that other processes are blocked. But if you're doing things linearly in one process, committing less often, you're allowing things to build up sort of in this cache that SQLAlchemy keeps, and then dumping it all to the database in one transaction.
Does flush only block if there's an expected conflict, or does it block every time?
That's a good question, and I believe it only, it will, I don't think the expected conflict is specific as these IDs are going to match. I think it means that this table has been locked because there's writes that are going to happen in this table. So I don't think it'll block. And again, this has to do with how everything's set up and which backend you're using. But I think if you're writing so this was to game, and then over here we tried to write to users, I think it would go through just fine because that table hadn't been locked up by another process. Yeah.
I have a question. If you're using Postgres, right, you can use actually the sequence, right? So why don't you use sequence for game IDs? So that usually may guarantee the number
Yeah. That's a great question. So the issue here is that the ID is provided to us from an external API, and we need that to store that ID so that we can query the API in the future. And we also want to put the constraint on the database that that ID is unique, so that we don't create like multiple objects with that same external ID. Yeah. Anything else? All right. I think I'm done a little early, but yeah, thank you.